All right, so first section in chapter 9 is on what we call parametric graphs and equations. So when you graph something, there's different types of graph systems you can use. Okay, so far this year we've been using what's called function graphing. Parametric is a different way to graph. It still uses an x and a y axis. Okay, so that part's going to stay the same for today. When we talk about another graphing system later in the week, we're going to talk about polar, and that does not use an xy axis. Okay, so that's a very different way to graph. But parametric is still kind of similar to what you're used to with the xy axis. The main difference is it's a different way of writing the equation you want to graph. Okay? And using this different way, you can get all kinds of different graphs. Some are a lot more complicated than we get into. That one's not super complicated. The one in the middle, that one is pretty complicated. Okay, the equation to draw that. And the one towards the end, that's not as bad. But if you notice, all of these graphs, they fail the vertical line test, okay, which means they're not functions. These three graphs are not ones you could draw on the calculator in function mode. Okay? I'm not saying every parametric graph has to fail the horizontal line test, vertical line test. Because you can still draw the kind of graphs that you've seen before. Like you can just draw straight lines, and you can draw parabolas and things like that. But you can draw a lot more. Okay, that's what parametric does. And one of the big differences, if you go to mode and go to parametric, and you look at it, when you want to graph an equation, okay, so look at like the blue one, there are two lines that you have to type in. Normally when we do function mode, you type in one line, and that's what you're graphing. Well, now you have to type in two. And I'm going to explain what each of them are right now. So we're going to call the two different lines that you have to type in, call them function f and function g. It's two different functions. They don't have to be trig functions. In that particular case, they are. And the first function, function f, that's going to be the function that's going to generate the x value in all of my coordinates that I'm graphing. Function g is going to generate the y value. Okay, so that's the big difference with parametric. Instead of having one equation that specifies everything, you have two. You break it down. One formula gives you the x value of your coordinate. A different formula gives you the y value. So if you take all the different values generated by function f, those are your x's. Take all the different values generated by function g, those are your y's, and you put them all together, generating all the different points you can from those two equations. What you get is called a parametric curve. Even if it is a straight line, they tend to still call it a parametric curve. And C, that's just the name I gave to the graph. Okay, that's the name of the curve. Just like we normally label things on the calculator like y1, y2, well, you could call the curve C1, C2. It's just the name of the graph you're looking at. And the two equations, the f and the g, the one that's generating all the x values in your coordinates and all the y values, those are called parametric equations. They always come in pairs. If you are trying to do something parametrically and you don't type one of them, it's like me saying graph this coordinate. You can't. You're missing half of what you need to graph it. Okay? And if you notice the variable they use, a lot of times when we do things in like function notation, think of like a a line, y equals mx plus b. The letter that changes in y equals mx plus b, the independent variable, is x. When you do things parametrically, the independent variable is t. Right? They just use a different letter. So now, when you press the button right below mode, the button has an x, comma t, comma theta, comma m. When you press it, it now is going to give you a t. Before, it gave you an x. Right, so it's just a different variable that we use. And they generally don't call it a variable, they call it a parameter. It's the same idea. The parameter is the thing that can change in your function. And we got to talk a little bit more about that. We'll get to it. Because when you go to window, we're used to seeing like x min, x max, y min, y max, seeing those things. But there's some extra things here. You still have x min and x max, y min and y max, x scale, y scale. That's all the same. But there's this t min and t max. That's a little bit different. Okay, so we'll talk about what that is and this t step. Okay, that's also very important when you're graphing. We'll talk about what they do. Okay, so a couple of things we're gonna try to do. I'm gonna give you equations and have you graph them. So we have to learn how to kind of set the window and set everything to be able to see it. The other thing we're gonna look at is how can we take something that's written this new way and change it back to the old way. Okay, that is doable. So we'll convert back and forth between parametric and function. All right, so just a word you might see in the book or thrown in there. If they ask you to find a parametrization of a curve, it basically means to find a pair of parametric equations that you could type in on a calculator to get the picture they want you to get. Okay, so the two equations, the two parametric equations, give you what's called a parametrization of the curve. So you'll see that word, you'll see the word parameter, parametric equation. You'll see those words kind of thrown around a little bit. Now, the other thing that's different about these kind of graphs is they can intersect themselves. Okay, we saw that on the first page. You can have graphs that cross over, and if they intersect themselves, it means they failed a vertical line test, which is fine. They're just not functions. Okay, I think the first three that I did, they all intersect themselves, cross over at some point. They don't have to. If I did something like, let's do, type this in, 6. Doesn't cross over itself. Just technically that is a well. Let me let you look at it a little closer. What shape is that?
An ellipse or an oval.
It looks that way.
Well, then
Yeah.
it's a circle.
It is a circle. If you measure the distance in every direction, it is 3 units. Up, down, left, and right.
Just because the graph makes it look weird.
Right. It's because the spacing between the y-axis tick marks and the x-axis tick marks is not the same. Right? So one thing we might have to do if we actually want to see something the way it should be, proportional, is zoom 5, and that'll make things look the way they should look. Right now, the spacing between the x and the y-axis tick marks is the same. Yep. But that's just an example of a parametric function that doesn't cross over itself. And if I change it just slightly, I can get something similar, but instead of a fixed radius, I can get a radius that's growing, but I have to zoom out quite a bit.
No, that's.
Now this looks more like a spiral. Okay. And if I keep zooming out, you'll see more and more of it. But that's all that a spiral is. It's really a circle with a radius that keeps growing. And that's another example of a parametric equation that does not intersect itself.
Archimedes spiral.
And I can control how much of the spiral we see. That has to do with this Tmin and Tmax. So if I make this a little higher,
Oh, now instead of one revolution, I'll do two.
yeah, I can see more of the graph.
Yeah,
Okay.
that's an Archimedes spiral.
So we can control how much of it we see. We can also control how smooth it looks. It still looks pretty smooth. You start to see it get a little jagged on the edges. But as I start to make this number higher, you're going to start to see it really get jagged now.
Oh, yeah.
So we can control, I guess, the amount of detail that you're seeing in the graph. The lower the detail, the faster it'll graph it. If I do really, really high detail, the problem with that is it's going to take a very long time. It is graphing it, but it's going to take a long time. Okay. So we have to kind of learn how to find a balance between what's enough detail to make it look the way it should, but what's too much that it's taking way too long to graph. Right? And keeping in mind the calculator only has a certain resolution on the screen. You can put more detail, but you might not even be able to see it. So the difference between that picture and this picture, which is going to draw 5 times as fast, I don't think you can see a difference at all. Yeah,
Unless
no.
you
You
zoom
can still
in.
see it's a spiral.
Yeah.
Unless you zoom in.
Yeah, maybe if you zoom in, you can see more detail, but yeah. All right, so when you draw something parametrically, it has what we call a start point and a stop point. Right? For that spiral, it started at the origin, and it stopped, well, when I did one revolution, stopped right there, started right there. That's one thing we want to be able to figure out. Okay, when we graph something parametrically, where does it start? Where does it stop? Now, where it starts and stops is dependent on the parameter. Okay? We can control where it starts and stops. So it's not like a graph with y equals where you draw it and, for example, a line might go on forever. No, we can draw a line segment. We can control where it starts and stops. And the way that we control that is with this Tmin and Tmax. If I didn't want this spiral to start at the origin, I could say start my Tmin at 30. Well,
You still really zoomed out.
I'm zoomed out a lot. Okay, I'm zoomed out into the thousands on the x and y, well, on the x-axis I'm in the thousands. So let me start at like 150. And I think, yeah, now you can tell the spiral doesn't start at the origin anymore. So we can control that. It has to do with the Tmin and the Tmax. The way that they're going to explain to you what the Tmin and what the Tmax is they're going to give you an interval. Here's a problem where they give you an interval, and it says it's the closed interval from 0 to 1. When they give you that, those are the numbers you're allowed to fill in for the t in the formula. So they will give you an interval. It doesn't mean that if you plug in numbers outside that interval, you're going to get an error, like you're dividing by 0 or taking square root of negative. There might be numbers outside this interval that are perfectly fine to plug in. But if they give you an interval and they say you have to stay between this number and this number, that's just what they want. Okay? Maybe they're trying to control where the spiral starts or stops for some reason. Okay? So there's 4 calculations you need to do to find the start point and the end point. this value, which is the low value, if you plug that in to both of your formulas, remember the one that generates the x's and the other one that generates the y's, this number will tell you where you are going to start. So the lower number controls the start. If you take the higher number and you plug that into your two formulas, the one for x and the one for y, that number is going to control where your graph stops. All right, now, let's say you know where a graph starts and you know where it stops. If you set a window, let's say you set your window on your calculator or something like this. And that's what you look at. Are you guaranteed to see the entire graph? Yeah?
No, because
No.
some point in the middle can be outside of there.
Hey, it could go outside of that. Right? Maybe your graph does something like this. So if all you look at is what's in that box, you're not seeing the whole picture. You'll see something because that's where it starts and stops. But you may have to zoom out more to see it. Now, if that was connected with a line segment, then sure, yeah, you're going to see the whole graph. Or even if it was some kind of simple, curve, maybe part of a parabola. Yep.
It could be a circle though, and it could be not even inside the box too.
Yeah, it could go outside a little bit. So yeah, you might have to zoom out to see your whole picture. Okay, that's the point. All right, so now let's see if we can look at a graph. This one's going to be a very, very simple graph. And just see where it starts and where it stops. Okay. What number here is going to control where my graph is going to start? Yeah.
First number, which is 0.
Which is 0. And can someone else tell me what number is going to control where it stops, where it ends? Yeah? The 1. Okay. So to find where this graph is going to start, we need to plug in a number for x. And we need to plug in a number for y. To find where it's going to end, I'm going to plug in a number for x. I'm going to plug in a number for y. Where it starts, that's controlled by the low value. Where it stops, the high value. And now we just figure out those 4 calculations. Okay, if I plug in 0 for t in the x formula, what will I get for an answer? Yep, 1. If I plug in 0 in the y formula, what will I get?
0. Or 1.
Plug in 0 for t
Oh, 2.
in y of t. Yep, yep, we're going to get 2. So this graph starts at the point 1, 2. And it's going to stop at, if you plug 1 in for t in the x formula, what do you get?
-1.
Minus 1. And if you plug in 1 in the y formula, you will get
0.
nope, not 0. Yep.
1.
Yep, you're going to get 1. Okay, 2 minus 1 gives you 1. So this graph is going to end at the point -1, 1. Now, when you draw something on the graph, any graph we've done all year, just go to function, type in anything. What direction does the graph draw in? Think about any graph that we've done all year. Yep.
Normally it's left to right.
Normally it draws left to right. Okay, so if you draw something, there you go. It always draws left to right.
That is what I was doing.
Think about if you go from the point 1, 2, which is over here, to the point negative 1, 1. Left 1, up 1. As you travel from the start to the end, what direction is that?
Right to left.
That's right to left. Right? It's this way. So if you watch the graph as it does its thing, it is going to draw right to left. And I know I connected it with a straight line because this graph is a line segment. So let's go to parametric. And let's type in our first graph. So we've got 1 minus 2t. Remember, to get the t, you just press what used to be the button for x. And 2 minus t. All right. Now, we got to go to window. Okay. I like to go a little bit beyond the start and the end. So I would say for our left window, let's go to negative 2 on the x min. And for the x max, let's go to positive 2. Okay, y min, we could do 0. And y max, we could do 3. Let's go 0 to 3. Now the t min and the t max, that's what they tell me for my interval. That's the domain. T min is 0, t max is 1. So we do have to set those. And now the t step. What I would do for this one is I would do 0.1. Okay, I'm going to explain what t step is in a second. But if you hit graph and you watch it quickly, it is going to draw right to left. But it's going to be quick. If I want to slow it down so you can see it,
It's not going to change much.
I could slow it down 10 times as much. Now you can really see it drawing right to left. And that's the graph of this picture. It's that line segment right there. All right, so now that t step, let's put it back at 0.1. And notice how much faster it drew it.
Because it's a line.
So when you change the t step, what you're controlling is from the start point to the end point, how many points do you want to put in between? Right? In the case of a line segment, you could really just get away with doing the start point, the end point, and that's it. When you do 0.1, okay, the way I have it right now, that means you're going to work with this interval. You're going to start at 0, and you're going to end at 1. Those 2 points you're definitely going to plug in for t. If you go by 0.1, you're going to plug that in for t, then that, that. You're going to plug in all these numbers. So you're plugging in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you're basically graphing 11 points, including the endpoints, to get your picture. So the t-step controls how many points you will graph. If I put it on 0.2, that's going to graph less points. Because what it's going to do now is it's going to start at 0, and it's going to grow by 0.2. So you're going to get 0, 0.2, 0.4, 0.6, 0.8, 1. So you're going to get 6 points going along your line segment instead of 11. How about if I did 0.5?
Oh,
How many points would it plot? Yep.
Total of 3.
A total of 3. It's going to start at 0. It's going to plug that in for t, plot the point. Then it's going to plug in 0.5, plot that point, and then it's going to plug in 1 and plot that point. So that would still be okay. Right? It's going to draw your picture extremely fast, but it's still okay.
it's a linear equation.
Yeah. Now, let's say I do 0.6, not a good t-step. Okay. What's the first number that it's going to plug in for t as it goes from the min to the max? Yeah?
0.6 or 0.
0. So it's going to start with 0. It's going to plug that in for t, get the answer, plot it. What would be the next one it would plug in? Yeah? Then it's going to do 0.6. It's going to plug that in for t and then graph it. What would be the next one that it would want to plug in after 0.6?
1.2.
It would want to do 1.2. But what's the t max? 1. So it can't do 1.2. So what's going to happen is we're going to lose part of our graph because we don't have the endpoint. Okay? And if you graph your line segment, you can see this time it doesn't look the same. You lost everything between 0.6 and 1. So what you want to try to do when you're graphing is avoid that gap at the end. So that easy way to avoid it is make sure that when you do your stepping, you end at a 1. So for example, stepping by 0.3, well, that would be better, but you'd still have a little bit of a gap. You'd get 0, 0.3, 0.6, 0.9, but then you're going to lose everything between 0.9 and 1 because it can't go above 0.9. The next one would be 1.2. That's over your max. Okay? That starts to become very important when you draw things that are curved. If you don't put in enough points, you're not going to get something circular. You might get something that has more jagged edges to it. And that's not usually what you want. Okay. So we try to make that gap at the end as small as we can. Okay. So any questions on what the idea of what t-step does? Now, you can also have the opposite problem if you make t-step too small. Okay. So if I put in like 0.0001, so now it's graphing by 10 thousandths. Okay? So it's going to graph every single number between 0 and 1, counting by 10 thousandths. Okay? That's a lot of points. Okay. What's going to happen now is it is drawing it. You can tell.
Plotting every single individual point on.
Right.
Slowly.
It's going to take too long. All right, and I don't want to wait for this to stop. So if you get stuck in a situation where you put in too high of a t-step and you see this yellow circle spinning, you're not going to be able to press anything until this yellow circle stops. We can make the yellow circle stop by pressing second and then off, and it'll stop. Okay. Now I can go in and say, oh, wait a minute, I put that way too high. Let's put it back to 0.1.
1 e to the negative 4th of that.
Yeah, so it did scientific notation. Okay. I would say depending on your curve, a straight line, you really don't even need more than 2 points. Okay. A curve like a circle, if you were going in degrees, if you plotted a point every 5 degrees from 0 to 360, that's going to give you about 70-something points on a circle. That's pretty good, counting by 5s from 0 to 360. But you'll start to get a feel for it as you graph more. Bless you. Okay, so any question on how to find a start point or an end point? Okay. So now let's try something a little different. Let's see if we can take an equation that's written parametrically and change it into an equation that's not. Okay, so we're going to change it back to what we're used to. And I think I'm going to use the one we just did. Okay, so I kind of want to save that picture first. So remember, this was parametric. So when you are asked to eliminate the parameter, that means to rewrite the equation, generally as y equals something, but no t on the other side. Okay. Anybody have an idea of what we can do to get rid of that t? So we want y equals, but we don't want a t here anymore. We want an x here. Yeah?
Couldn't you do x minus 1 divided by -2 to replace it?
Yeah.
So you remove all the variables from the other side of t.
Yeah. So we're going to solve that first equation for t, and we're going to substitute it into the second one. Yeah. So if you solve it kind of step by step, you get x minus 1 equals -2t. And x minus 1 divided by -2 equals t. Let's clean that up a little bit. If you're going to divide by -2, we can divide each part of the numerator by -2. So that would be, think of the x as having a 1 in front of it. That's -1/2 x, and then -1 divided by -2 plus a half. Okay. So there's your formula for t from the first equation. And now plug that into the second. That is how you eliminate the parameter. Every time. Solve the x equation for t, and then plug it into the y equation.
So now it's just the inverse.
So now we get 2 minus -1/2 x plus a half. So this is going to end up being y equals mx plus b, because we already know what it looks like. It's a line segment.
So y equals 1/2 x.
So we got 1/2 x. That's my slope. And then
1.75 or 1.5 or 1.5.
yeah, 1.5 or 1.5. There you go. So that's how you change it from parametric back to function. So let's graph that now and see if it looks the same. If we did everything right, it should. Okay, so I saved that picture already on the other page. When you go back to function, it will automatically carry your window with you. Okay, so the x-min and x-max and all that, it copies over. The equations don't, because it's function versus parametric. Excuse me. Okay, so I did 0.5x plus 1.5 just because it's easier to type in. I'm going to hit graph, and let's compare that.
So it gives the full formula rather than just the small snippet.
It's a different direction though. It draws in a different direction.
Yes, it will always draw left to right in function notation. But I want these to look identical. If they don't look identical, then there's something missing. Okay, so this is what we get as a function. Are they identical?
Yes.
No,
They are?
because one is a line segment and one is a line.
Yeah, one's a line segment, one's a line.
Ah.
So we need to add something to this function. We need to add a restriction to it.
Yeah, we're gonna set the window.
We need to tell, well, not even the window. We need to actually stop the actual graph from drawing, right? Because this is going forever. Even if I zoom in on it, so all you see is that part, it still means it's drawing it outside the window. Okay, so we don't even want it to draw it. So what we have to do is control where it starts and where it stops. So what we have to do is when you rewrite it as a function, you have to restrict the domain. What do you have to restrict the domain to? Well, look at where the start point and the end point was. That's what's going to tell you where to restrict it. So we're going to add that onto the bottom. Let's look back at our start point and end point for the line segment. Okay, so the farthest left that it went was -1, and the farthest right that it went was +1. When you're doing a line segment, your start and your end point will tell you your domain. If your graph did other kinds of crazy curves, you may have to look at it and just figure out somehow how far left to go and how far right to go. So I want -1 to +1. Now, if I change my graph and I draw this, it should look as close as I can make it to the parametric. Okay, so how do you type in a condition? Does anybody remember what I have to do with this so I can type in a condition next to it? Like that. I have to do something with that first. Yep.
Like a piecewise function?
Yeah, we're gonna, well, we're not gonna put in two different equations, which is usually what you do with piecewise. We're just gonna put in one. But we're gonna put in a restriction on the domain, but I need to be able to type that in. So anybody remember what I have to do to put in that restriction? So you have to take the original function and put it in parentheses. And then next to it, we can type in our restriction. You do have to type that in as two separate ones. I don't think you can do it all as one. So I want x to be greater than or equal to -1. So x, and then press second math. That should take care of the left side. There you go. And now I also want it to stop at +1. So put in another restriction next to it.
This is less than or equal to 1.
Second, let's go back here, second math, option 6 and 1. So now it's drawing it as a function, but with the restrictions that make it look like it's the parametric one. Okay. Now, I know it's drawing this blue part on the bottom. Well, when you're in function mode, the calculator is going to try to draw everywhere. There's nothing I can do to fix that. Okay, it's going to draw that. When it tries to draw somewhere that it doesn't have a formula for, which is everything below -1 and everything above +1, it just defaults to drawing on the axis. Just what it does. But that's what I'd be looking for to change it from parametric to a function. First, make sure you give me the formula, and then second, make sure you give me the restriction on that formula.
It's like a skateboard route.
Okay. Any questions on that one? Yeah?
Can you go over again how you got the restriction?
So the restriction I got by looking, when we did it parametrically, I knew my start point and my end point was at -1 and +1. +1 and -1. And that's as far left and right as it went. Now, if it wasn't a line segment, but it did something like this, well, now -1 and +1 doesn't tell you much. You've got to figure out how far left you go and how far right you go. And how you figure that out, well, that could be hard to figure out in that case. So we're not going to have one that complicated. Let's try to eliminate the parameter here. So I'm looking for an equation, and I'm looking for a restriction on the domain. The only way you would not have a restriction when you change it is if that was -∞ to infinity. That's different. Now you're saying you can plug in anything you want. Okay. All right. So what's my first step to get this in y equals format? Yep.
First, you find your starting at points.
Okay, I'll worry about that after because that's going to help me with my restriction. So yes, I do need to do that. Let's focus on the formula first.
All right. Uh,
Yeah.
Find an equation for x or t.
Okay, and which one are you going to work with?
I'm
to
gonna
do
work
that?
with the one with x. 'cause
Yes.
That helps define a function.
What would t equal in that top formula?
T equals x plus 1.
T equals x plus 1. And now, what do we do with what's in that box?
We turn to a y equals equation, so it's no longer y equals t squared, it's y equals x squared plus 1.
yes, this one's for.
So what am I going to write?
X plus 1 squared, not that.
Right, we're going to fill this in. If you want to do that out, that's a binomial, right? So if you change that, you get y equals x plus 1 squared. Or if you want to do it out, x squared plus 2x plus 1. Either, whether you do it out or not, unless the directions say, I don't care about that part. All right, so now what shape is this graph?
A parabola.
It's a parabola, but it's only supposed to be part of a parabola. So now we need to figure out where to start and where to stop. Easiest way to do that, graph it parametrically and see if you can find the left edge and the right edge of your graph. And I told you it wouldn't be that hard to find. So let's put it in parametric. Let's do 0 to 3. Stepping by 0.1 is fine. That's going to graph 30-something points. That's plenty. Let's do y equals t minus 1 and t squared. Okay, I'm not sure I'm seeing everything. So what I'm going to do is look up a little bit higher, and I'm going to go a little bit lower. So let's set our y max at 5. Whoops. Y max. Actually, you know what? I'm going to go to 6. And let's try -2. Okay. Still don't think I'm seeing the max. Let's try 12. Oops. Okay, I think I'm probably high enough now, but let's go a little further to the right. Okay. Once you see it stop and you have white space around it, then you know you've found the end. In this case, finding the start point and the stop point will tell you how far left and how far right the graph goes. Because it's not like the graph does something like that. In that case, the start and stop point would not be helpful. All right, so let's find the start and the stop, and all you need is the x value. Okay, you don't need the y value, because when you describe domain is just about how far left and right you go. Okay. All right, so what number here is going to control the left edge of that graph? How far left it goes? Oh, Moises?
Repeat the question.
What number is going to control how far left the graph goes?
0.
0. So we're going to plug in 0, and we're just plugging into the x formula. 0 minus 1, -1. So this graph goes to -1 on the x. And what number is going to control the right edge of this graph? Yeah, Holly. 3. And if we plug in 3, 3 minus 1 gives me 2. Let me just check. 2 seems low. Oh, well, my x max only goes to 4. So yeah, 2 is like halfway. So yeah, it's 2. So this is the parabola, just the section from -1 to +2. Okay. Any question on that one? Okay. Now, if you can't solve that equation for t, if you can't get t by itself, you are not going to be able to eliminate the parameter. Here's an equation where you cannot solve it and be able to get the t alone. Say you had x, let's see, what would be an equation? X equals t plus 3 to the t. You're not going to be able to get t alone. It's not possible. So if you had that for your x equation, you couldn't do what we just did. So if I ask you to eliminate the parameter, it'll be something that is doable, like the last two. But you can always reverse it. You can take anything that's not parametric and make it parametric. It's kind of a cheap way to do it. But this will always work. If you just change all your x's to t's and write y equals your function in terms of t. Okay, so let me kind of show you how that would work. Say you had this equation, and I said to you to rewrite that parametrically. Well, if you just write down x equals t, and then you write y equals 2t plus 4. That is the parametric way to write that. Because now do what we just did, change this back. Your first step is to solve the x equation for t. Well, it already is. T equals that. So now, in your y equation, everywhere that you see a t, fill in the formula that we got from the first equation. And it turns back into y equals 2x plus 4. So it's just kind of a cheap way to make something parametric, but technically it does work. Right. So let's try that one more time on this one. Okay. So how could I write this one parametrically using those two equations? Yeah?
Set x to t, or
Yep.
x is t.
So x equals t.
It would be y equals 3t to the fourth plus 7t to the third minus 8t to the second plus 2 to the fourth.
Yep, that's it. So it's actually pretty easy to change something to parametric, as long as you're allowed to do that. Right? And if you want to check it by reversing it, solve your x equation for t, already is, and then everywhere you see a t, fill in the formula that you got, which is just x. And it changes it exactly back to what you started with. Generally, there is more than one way to write something parametrically. You may have to play with the t-min and the t-max to generate the same picture, but there's definitely more than one way to do what we just did right there. But that's the simplest. Okay. All right. So the next one I want to draw is a circle. So this is going to be our first parametric graph that has a curve to it. And now the t step becomes a lot more important. Let's think about how we would describe not an entire circle, but just a single point on a circle. Here's a circle. And here's a point right there. If you wanted to describe that location of this green dot, how do you describe it? Or how do you describe the location of any dot like that? You need to give me a what? Yep.
X and Y coordinate?
You need to give me an x and a y coordinate. So think about how you're going to get the x and the y coordinate for that green dot. X is how far over, y is how far up. So anyone have an idea how we would figure out the coordinate for that point? Yep.
Well, if it's in the circle and we know game, maybe we can use some trick to figure it out.
Okay, so can you tell me, like, what would you have to draw to figure that out?
Oh, right triangle.
Yep, you'd have to make a right triangle, just like that. And just like that. And what would your hypotenuse be? It's really the, yep.
X, the square root of x squared plus y squared.
Okay, but we're going to think in terms of trig.
Oh.
So your hypotenuse is really your what in this shape? Yeah,
It's the radius.
it's the radius, right? So the hypotenuse we could call r. Now for a circle, that has to stay the same. If the radius isn't staying the same, then you could get a spiral or something else. But we have to keep that value fixed. So what in this triangle would change to start rotating that point around the circle? So that's a 90, so that's not going to change. That has to stay 90 all the time. That r has to stay the same all the time. So what would change in that triangle to make that point start moving to a different location? Yeah?
The two legs.
Yeah, the two legs are going to change. And the two legs are going to be controlled by that angle right there. As you change that angle, the legs in the triangle are going to change, and that's going to change the location of the point. Now, we need to name that angle. Let me just draw it a little bit bigger. We're going to do this parametrically. What did I say that we always use for a variable parametrically? What's the letter we use? Yeah?
T.
We're going to use a t. The t is the thing that can change in your problem. As t grows, changes the legs in the triangle, which rotates the point around the circle. Let's call this x, and let's call that y. What would be my formula for x using trig? What would be my formula for x? I know you had a good trig teacher. I'm pretty sure. So this is where we need to know trig.
Not everyone had the same teacher, so.
Well, we learn this.
Wait, do we know the angle?
Yeah.
Wait, do we know the angle?
No, it's going to be a variable. It's going to be t. So t is your angle. Yeah.
What are we finding again?
We're finding a formula for x using the radius and the angle.
Oh. I think that would be.
Yep.
R times cosine t equals
Cosine t. That's your x. And what would be the formula?
R times sine t.
R times sine t. Yep.
Okay.
Those are the two equations you need to write a circle parametrically. It's r cosine t and r sine t. So now they're telling you specifically they want a circle with radius 2, and this is automatically at the origin. If you didn't want it at the origin, you can shift it, but we're not shifting it right now. So could somebody tell me what my x formula would be specifically if the radius was a 2? Yeah.
Cosine t?
2 cosine t. Yep.
And then 2 sine t.
2 cosine, not cotangent, 2 cosine t, and 2 sine t. Yep. Now let's graph that. So let's put in 2 cosine t and 2 sine t. So 2 cosine t describes the x position of the coordinate on a circle, and 2 sine t describes the y position. Now, we're using trig. In order to get a full circle, you have to know what the parameter should go from. And we kind of looked at this with a spiral.
Yeah.
Where would the parameter start, and where would it have to stop in degrees? Because I'm in degrees. Yep.
360.
It has to go through 360 units. I think the easiest way is to go from 0 to 360. Now, stepping by 0.1, way too much. If you count from 0 to 360 by 0.1, that's over 3,600 points. Okay? If you take the difference between your Tmin and Tmax and divide by your T-step, that roughly tells you how many points it's going to plot. Okay? So I would say if you go by 10, that's probably going to look okay. It's going to plot 36 points plus the end point, 37. So you're going to get 37 points from the start to the end. Now, this is a circle with radius of 2. So if you go -3, whoops, don't do that. If you go -3 to 3, and -3 to 3, it is going to fit on the screen. It's going to look like an ellipse because the screen is not square. But I can fix that by doing zoom 5. And there's a circle of radius 2. Now, 10, going by 10s, that was fine. If we go by 20s, okay, first think if you count by 20s, do you end on 360? Counting by 20s.
Yes.
Yeah, you'll still end on 360, so that's okay. A little bit more jagged. Okay, I'm starting to see the edges. And now, if I go by 60s, will I end at 360? But I'm not going to get a very good circle. In that case, I get a hexagon because it plots 7 points, but the 7th point and the 1st point are the same. So you only really get 6
So that's not a circle.
distinct
Something
points.
wrong.
No, wait, is that? Yeah, so 7 points, right? 1, 2, 3, 4, 5, 6. And the 7th point is a repeat. Yeah. Okay? So you got to set enough detail so that it looks like a circle. 10, that's fine. Now, what if I go by, go by 50s? Am I going to end at 360? No, I'm going to end at 350. So what's going to happen this time is, first of all, I don't need to get a smooth curve. Second of all, I get a gap. I get a gap because I lost everything between 350 and 360 because my T-step was not a good value. Okay. And so again, 10, even if you go by 5s, I think 5, it'll still draw reasonably fast. A little slower. But that's fine as well.
Oh, I'm in radians. You can change that.
Yeah, if you're in radians, then you got to do a whole different thing. Instead of going 0 to 360, you got to go 0 to 2 pi. And then that's 0 to 6.28, so I'd probably go by 0.01. That'll graph you about 62, 63 points going around the circle.
Yeah, I was graphing it like a star for me, so.
So notice the domain was -2 to 2, and the range was -2 to 2. But the domain for the parameter is 0 to 360. If you don't make it 0 to 360, you will not get a full circle. That's 0 to 270. Okay, that's 3/4 of a circle. So you've got to go 0 to 360 or 0 to 2 pi if you're trying to do something with trig generally to get a full picture. Okay, so the last one, I think just a couple graphs. Yeah. let's look at this one. So generally what we have to do is figure out our window. That's the hardest part. Let's focus on x first. T cosine t. That's not going to be a circle, okay, because it's got something in front of it that's a parameter that's changing. So it's like a circle where the parameter is changing all of the time. Think about cosine t. What's the biggest that cosine can ever get? Just regular cosine. Yeah? 1. So the biggest that this part can get, that I just underlined in red, is 1. What's the smallest that it can get?
0. Or no, -1.
-1. So this part is always between 1 and -1. 1 and, I'll write it like this, -1 and 1. Now, if you multiply that by 4 pi, what would be the biggest and the smallest the x could get?
4 pi and -4 pi.
4 pi and -4 pi. You are guaranteed to never go beyond 4 pi and -4 pi. And we are going to switch to radians. Is that overkill? Yes, probably. You probably have way more than you need. But guaranteed you will never go beyond -4 pi and 4 pi. And now look at sine. What's the biggest and the smallest that sine can get? Yep.
-1,
That's also -1 to 1. And if you multiply that by the biggest possible value you could ever have for t, which is 4 pi, what is t sine t guaranteed to stay between? Yep. Right, it won't go beyond -4 pi and 4 pi. And that's if everything lined up just right, that you had like the biggest value you could when you plug in for sine t, and it lined up with plugging in 4 pi. Okay? But you'll never go beyond -4 pi to 4 pi. 4 pi to 4 pi. And now we need to set our t-min and t-max, and we're using a sine and a cosine function. What do I have to set t-min and t-max to get a full picture? Yeah?
T-min would be 0.
Yep.
And T-max would be 4 pi. Unless 2 pi?
2 pi. Yeah. Do they tell us?
They,
Oh, no, they do tell us
yeah,
4 pi. I'm sorry. Yeah.
Even though it is,
It's just going to go around more than once.
yeah, it's a spiral.
But that's what they want. They want it to go around twice. So we'll make it go around twice. T-step, 5 is an awful idea. You're going to get 0, 5, 10. If you graph that, well, first of all, you got to put it in radians.
Forever.
No, it's going to draw pretty quick, because it's only going to draw 0, 5, and 10. But I thought I put it in radians. No? It looks awful. That is not what it's supposed to look like. So a good value to step by would probably be 0.1. Now, is there going to be a little bit of a gap at the end? Yes. Because when you count by 0.1, you're going to get 11.9, 12, 12.1, 12.2, 12.3, 12.4, 12.5. And then you're going to go to 12.6. So you're going to lose everything between 0.50 and 0.60. So you're going to lose a little bit from 0.50, actually 0.50 to 0.56. So you're going to lose that. But it's going to be such a small gap, you probably won't even notice. Okay, it should end. Oh, did I not type my equations in yet? Make sure you actually put in the problems that they tell you to. T cosine t and t sine t. And it should end right on the x-axis, but there might be a very small gap. Yeah, just a little bit. But that's not bad. Okay, if I want to avoid that, I can probably just make my t-step a little smaller. Okay? It's going to draw a little slower, but you'll probably see less of a gap now, because it's going to get all the way to 12.55 with the parameter, and I'm supposed to go to 12.56. Can't even tell. Yeah.
So for another way to do the t step, could you also do like 0.1 times pi to get it exactly on the line?
Yeah, you could use some multiple of pi to try to figure it out too, if you want.
You could also do pi over a number.
Yeah, you don't
I did
have
pi
to,
over 12.
but if you want to, you absolutely could. Yeah. All right, let's do one more and see what happens on this one. Okay, let's look at this part. Sine is always between what two numbers? Yeah? And what if you multiply that by a 5? Okay. So it's on our x, we're never going to go beyond -5 to 5. No matter how big you let t be, even if you let t be 20, the sine of 20 is still going to be between -1 and 1. Okay? How about cosine? That's always between what two numbers? Like it?
-1 and 1.
It's always between -1 and 1. And now think of 5t. What's the biggest that 5t could ever get? Yeah.
Would be 5 times 20.5, which is...
Yeah, 5 times 20.5. That's as big as the front part could ever get, 102.5. So this will never go beyond 102.5. And if you multiply that by 1, well, you get the same thing. And -1 is -102.5. So you'd be safe if you go like 103 to -103 for your y. -103 to 103. Okay, we're using a trig function again. They want 0 to 20.5. And, well, that's too much, 0.05. I would say maybe, let's do 0.2. Okay, if you go by 0.1, you're going to get about 200 something points. If you go by 0.2, you're going to get about 100 something points. It's probably pretty good.
But I don't think 0.2 can ever just not multiple 0.5.
Yeah, so the best you're gonna get here is you're gonna get to 20.4. You are gonna lose 0.1, but it's not enough that you're gonna notice.
You change t step to 2.5, of course, though.
So 5 sine t, and then 5t cosine t. But yes, there's gonna be a 1/10 gap at the end that you shouldn't see. But that's okay. You'll still get a really good picture of what this looks like. And I doubt you'll even see the gap. There you go. All right. So that's what that picture looks like. And the more that you expand t, the more kind of stripes across that object you would get. But you are always stuck between -5 on the x and +5 on the x. It can keep growing up and down forever. Okay. Yes, it can keep growing forever this way. All right, so any questions on that? So that's parametric equations. So that is the homework. Some of it is just, actually I think, hold on one second. We can make that a lot simpler. Let's say, it's 1 through 17 odd, and then 21, 22, 25, 26, and 29 to 33. So some of that is just sketching on the calculator, kind of practicing finding a window. And then some of it's eliminating the parameter and finding start points and end points. So we will take a look at that.